All right. So linear and nonlinear functions. Okay. Linear is exactly what it says. It's a line. Okay. So with linear, you can think line. Okay. Not a curve, but a line. All right. So linear functions, it's a line. So these are basically, you can think of them as a straight line. Okay. It also has no curve. So we're going to draw a couple examples of linear. So draw me just a little graph here. This would be linear. Okay, it's a straight line. It's a linear function. All right. There's no curve to it. I mean, there might be. I'm not an artist or anything. I'm not. I can't draw a perfectly straight line. I'll try my best. Another example of linear would, if I had a decreasing line. Okay, these are both linear. All right, they're both straight lines. Okay, there's no curve. Those are linear. So linear, you can think of line. Okay, because they actually the word line is in linear. All right. So that would be an example of a linear function. A nonlinear function, okay, this is a curve. All right, these are curves. So an example of this would be something like if I had a function like this, or you might have something that looks like this. All right, notice with these, they have curves. Okay, so that's a way to identify linear and nonlinear in a graph, in a graphing form. Okay, these have curves. They obviously have a bunch of different curves. These lines will go different directions. Okay, these lines up here are just straight. There's no straight, 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 straight like this. No, they're just a straight line. Okay, there's nothing in it that interrupts it. All right. Now, here's what these would look like as an equation. Okay, so your linear as an equation. All right, one thing to remember here, no exponents. Okay, these have no exponents. So an example of a linear equation would just kind of look like this. It might be y equals 4x plus 3. That's linear. There's no exponents there. Okay, so if I wrote 5 equations down and I wanted you to identify whether those were linear or nonlinear, yes, you could graph them. That might take a while, but you could graph them. Okay, or we could give you little hints to let you know, hey, this is linear, this is nonlinear. Okay, an example of a nonlinear equation. What do you think this has? This has exponents. Okay, this one has exponents. So an example would be y equals, I don't know, 3x squared plus 7. You have an exponent right here. Okay, so if your x term is squared to the 7th power, cube, whatever, it's going to be nonlinear. If your x is just by itself with no exponents, then it's linear. Okay, so no exponents, this has exponents. All right, everybody good there? All right, we're going to move on to the next part of the notes. And the next part of the notes is what I've been getting a lot of IXL questions about. All right, so this is going to be writing a function rule. Okay, so we're writing a function rule. Whoops. So with your function rule, okay, something we need to think about is it's going to look like, I've been really bad at writing today, look like slope-intercept form. And what we need to remember from slope-intercept form is what it actually is. Y equals mx plus b. Okay? Y equals mx plus b. So, this is probably going to be a review for a lot of you. What's m? M is my slope. And what does slope equal? The difference in x over the difference in y. Okay? So one thing to remember, difference in x over difference in y. Remember our charts that we've been filling in. What do those charts have? They have an x and a y. Okay? So keep that in mind. So our slope is our difference in x over our difference in y. Your b, this is the y-intercept. And what is the y-intercept? This is when x equals 0. And I want you to underline x equals 0. So it's when x equals 0. So let's do an example here. Example 1. You're going to have example, it's going to say write a function rule from the table. And it's going to have a table that looks like this. It's going to have an x and a y. And we're going to have different values. So we'll say -1, 0, 1, 2. Let's go 5, 1, -3, -7. We're going to write a function rule. Now, one thing to pay attention to. Sometimes they might try to trick you and skip x values. They might do the same for y. So make sure that we're looking at our x and y's instead of just looking at two of them and assuming, okay? So our function rule needs to look like this. Y equals mx plus b, okay? So the first thing we're going to do, we'll write it right here. So step 1, we're going to find our x and y patterns. Remember our patterns, these are our differences in x and our difference in y. Okay? So let's look at x. From this x to this x, what's happening? Well, we're adding 1. -1 plus 1 is 0. From here to here, we're adding 1. Here to here, we're adding 1. So do we have a pattern? Yes. Our difference in x, remember it's difference in x over difference in y. So our slope, we're adding 1, so that's 1. Okay? And now let's look at our y. What's happening from here to here? Well, we're subtracting 4. Here to here, subtracting 4. Here to here, subtracting 4. So my difference in my y's is -4. Okay? So I'll write that out here. This is the difference in x. This part right here is the difference in y. Okay? And so this part will go where my m is. So negative 1/4. And then step 2, we're going to find the y-intercept, okay? And if we go back to our definition of a y-intercept, our y-intercept is when x equals 0. So look at the table. Look through our x values. Is there any point where x equals 0? Yes, x equals 0 right here. Well, what's y when x equals 0? Y is 1. So your y-intercept is equal to positive 1. Okay, because it's positive 1 right here. So my b is just positive 1. And here's why I write positive 1. Okay, this will not always be a plus sign. All right, if my y term was a negative, then it would be minus whatever that number is. Okay, but it's a positive, so it's going to be plus 1. All right, so when I rewrite this for my function rule, my new function rule is going to be f of x equals whatever I have up here, which will be negative 1/4 x plus 1. And that will be the answer to my function rule. Okay? You're just finding a pattern in x, then you're finding a pattern in y, and we're using what we know from slope-intercept form. Okay? And then you're writing your function rule. And the easiest way to do this is to make sure you remember that it is in slope-intercept form. Okay? So your slope is your difference in x over your difference in y, and then your y-intercept is when x equals 0. Now, what if you get a table where x doesn't equal 0? What do? Well, that's where you count back to 0. So let's look at an example like that. Okay. So example 2. Again, it's going to be write a function rule. And let's say we have 2, 4, 6, and 8. And let's go negative 11, negative 8, negative 5, negative 2. So we're going to write our function rule here. Okay. Remember, our function rule needs to be in slope-intercept form. So first thing, let's find our slope. Difference in x over the difference in y. So let's look at my x's. From here to here, I'm adding 2. Adding 2 again. I'm adding 2 again. So I know that my top number for my slope is going to be 2. It's my difference in x. And my y's, from here to here, we are adding 3. Adding 3 again. And adding 3 again. So this on here be a positive 3. So my slope is going to be 2 over 3. Okay. Now to find the y-intercept. But Mr. Reed, there's no x value that is 0. We're going to have to count back to get to 0. Okay. So if I kept this going, obviously this would go to 10 because of my pattern, but 10 is getting me farther from 0. So I need to start up here. I'm going to work backwards. Now, if I go from 2 back, okay, if I'm going this direction, we're adding 2. When I'm going back up, I'm subtracting 2. So to subtract 2, that gives me to 0. That's exactly where I need to go. So now look at my y's. I need to get back to this value. Obviously, we're adding 3. So when I work backwards, I need to subtract 3. And negative 11 minus 3 is negative 14. So now that x is 0, my y is negative 14. And that gives me my function rule of y equals 2/3 x minus 14. And that is going to be the function rule for that table.